every life matters. Let's now go on by looking at differentiation, and now today we are going to look at the techniques of differentiation. And when we talk about techniques of differentiation, we are talking of the various techniques we use to differentiate functions, otherwise to find the gradient function of different functions. And there are majorly three techniques in differentiation. We have the chain rule, product rule, and the quotient rule. There are basically three of them. And now let us start with the chain rule. What you have to know is that we have heard of the chain. A chain is actually made up of particles that are all joined. They are joined at different joints. That is what we call a chain. So in chain rule, we join different derivatives. And the chain rule states that dy over dx is equal to dy dt times dt dx. This one does not matter. It will be dA, it will be even du, depending on the unknown that you have in the question. It is dy over dx is equal to dy dt times dt dx. Otherwise, what I'm trying to observe here is that in quotient rule, you join this function but with an intention of having all the sides equal. You make sure that all the sides you are having dy over dx. Because on this side you are having dt, you can choose to cancel them, it remains dy dx. That is chain rule. And now let us look at the example. Differentiate y is equal to x plus 2 power 100. You can use that first approach, you drop the power, times, then you reduce the powers. So here we are, y is equal to x plus 2 power this. So in chain rule, we aim at having one solid base. We aim at having one base and one power. So what we do is that we let t be equal to this bracket in such a way that we are going to have one base. So we let t to be equal to this bracket. The t represents whatever is in this bracket. And what you have to know is that whenever we let, we differentiate. And it will not be dy dx, no. It is the d of what is on this hand divided by the d of the unknown on this side. On this side we are having t, and on this side we are going to have x. So we'll differentiate t in respect to x. Differentiate what is on this side in respect to what is on this side. So it will be dt dx. The change in t over the change in x, we differentiate this. We get 1. This one is a constant 0. We differentiate this, we get 1. So dt dx is equal to 1. Right? So we come into this equation, it was y is equal to x plus 2 into bracket power 100. But remember, we are aiming at one base. And remember, we let the one of brackets to be t. So where there is this bracket, we put t. So it will be y is equal to t power 100. It's from this, just as this one is equal to t. So where there is this, we put t. So, and we are having y is equal to t power 100. So we are going to differentiate y in respect to t, dy dt. We drop the power, which is 100, times the original, but reduce the power of this one by 1. It is going to be dy dt equaling to 100 t power 99. We are having dt dx and dy dt. We are having these two specific functions. But remember, we talked of a chain. We combine, we join. So we are going to join this one and this one using chain rule. And chain rule, we know that it states that dy dx is equal to dy dt times dt dx. Then you substitute. Dy dt is the same as 100 t power 99. We bring it here. Times dt dx. Dt dx is equal to 1 times 1, you get that. So dy dx is the same as 100 t power 99, because anything times 1 remains. But remember, in our question, we are not given t. We just introduced in this t. But remember, but t is the same as x plus 2 from here where you let. So you are going to just from this divide x function where there is t, put x plus 2. So finally, y over the x will be 100 into x plus 2 power 99. Hello guys, thanks for watching. Don't forget